Hello students, today we'll be going to discuss the lesson electrolysis. I have already discussed about electrochemical cells with you, and as I told you, today I'm going to discuss electrolysis with you. Let's see what is electrolysis. The chemical changes brought about by passing electricity through a solution which conduct electricity is called electrolysis. When I was teaching the electrochemical cells lesson, I told you that in electrochemical cells, we do not supply external electricity. The difference between electrochemical cells and electrolysis is here we are supplying an external electricity. We are giving it an external source of electricity. So when we are supplying electricity to a solution that conducts electricity, some chemical changes will take place. We will call these chemical changes electrolysis. So I think you understood what is electrolysis. Let's see an example. In this lesson, children, first, just like in electrochemical cells, you should be able to identify the anode and the cathode. How can we identify this anode and the cathode? I will teach you step by step. First, what you have to do is you have to identify what is the positive electrode and what is the negative electrode. You can see in this setup, we have used fused sodium chloride as the electrolyte, and as the electrodes we have used two carbon rods, and we have connected this to an external electricity supply. So because here we are connecting it to a external electricity supply only, we are calling this setup electrolysis. Okay, now first we are going to identify what is the positive electrode and what is the negative electrode. You can see this electrode. This electrode is connected to the positive terminal of the battery. So this electrode becomes the positive electrode. Okay. Now you can see that this electrode is connected to the negative terminal of the battery. So this will become the negative electrode. Okay. Now what will happen? You know that always the positive gets attracted to negative and the negative gets attracted to positive. So now here we are using fused sodium chloride as the electrolyte. Okay, when we are supplying electricity, what happens? This NaCl breaks into two. It breaks as sodium plus ions and Cl minus ions. Now in the solution, sodium plus ions and Cl minus ions are present. As I told you before, the positive gets attracted to negative always. So what happens? This sodium plus ion slowly it will move towards this negative electrode. This sodium will move towards the negative electrode. Okay. Then what will happen to this Cl minus ion? Cl minus it is a minus ion. You can see this side there is a positive electrode. The minus or the negative ions, what will the negative ions do? They will slowly come near the positive electrode. So the Cl minus ion will come near the positive electrode. Okay. Now, what does this sodium plus ion do? It will go here, and you can see when we supply electricity, electrons are flowing from the positive electrode to the negative electrode. So these electrons will come and get embedded on this carbon rod. There will be electrons like this. Okay, electrons will get embedded in this carbon rod. Now what does this sodium plus ion do? It will combine with one of these electrons and it will form sodium. This sodium plus ion will combine with one of these electrons and it will form sodium. Let's see the equations in the next one. Okay, you can see the equations. These are the equations related to our first example. The sodium plus ions, it went near the negative electrode and it took one of the electrons and it became sodium. Then what happened to those Cl minus ions? It went near the positive electrode, it released Cl2 gas and it formed Cl2 gas and it released 2 electrons. Okay. Now I have taught you how to take the overall reaction in the electrochemical cells also. In the same manner, we have to take the overall reaction here. What we are doing is we will mark this as equation number 1. And we will mark this as equation number 2. Okay. We have to add this equation number 1 and equation number 2. Here we are using the method of simultaneous equations in maths. You can see here 1 electron is there, here 2 electrons are there. Then it is difficult for us to cancel these 2 electrons. So for us to cancel these 2 electrons, this electron also should become 2. So because of that, what I am going to do, I am going to multiply the first equation by 2. Now here you can see I have multiplied the first equation by 2. Then I will get 2 sodium plus ions, 2 electrons and 2 sodium. Now I can add the, now I will mark this as the third equation. I will mark this new equation as the third equation. Okay. Now I am going to add the second equation and the third equation. The ones on the left hand side, Cl minus and Na plus and 2 electrons will come this side. And the ones on the right hand side, that is 2 sodium and chlorine gas and 2 electrons will come on this side. Then this side also there is 2 electrons, this side also there is 2 electrons. What will happen? These 2 electrons will get cancelled for these 2 electrons. Then you will get the final reaction as 2 Cl minus plus 2 Na plus gives 2 sodium and releases chlorine gas. Okay. Let's come to the next slide. The next example is electrolysis of aqueous sodium chloride. Here we are using aqueous sodium chloride. You can see. Here we are using aqueous sodium chloride. Because we are using aqueous sodium chloride, aqueous means water is also present here. Sodium chloride will break into 2 as sodium plus and Cl minus, and aqueous means water is present. Water will break as H plus and OH minus. Now here there in this solution there are 4 ions and the 2 electrodes are there. So as I told you, our first step is we have to find out what is the positive electrode and what is the negative electrode. Now this electrode is only connected to the positive terminal of the battery. So this will become the positive terminal. Okay. And this electrode is connected to the negative terminal of the circuit. So this will become the negative electrode. Now we know that positive will get attracted to negative and negative will get attracted to positive. So now here there are 2 negative ions and 2 positive ions. Now there will be a small competition here as to like who will go near the electrode and who will get reduced like that. Okay, now the 2 positive ions are there, sodium plus and H plus. Now this one also wants to go here and get reduced and this one also wants to go here and get reduced. But whom do you think will get the chance? There is a method of identifying this. In the first video, I mean like in electrochemical cells, I taught you about the activity series. You have to go and check in the activity series who is at the bottom, sodium or H plus. If you go and see, you can find out that H plus is at the bottom. So that means the H plus will only get the chance to go near this negative electrode and get reduced. So what happens? This H plus will go near this negative electrode and it will get reduced. Then now two negative ions are also there, Cl minus and OH minus. From these two, Cl minus will get the chance of going here and Cl minus will only get oxidized. You can see the reactions. Now because here H plus is going here and it is accepting electrons. Here also electrons are coming and getting embedded on this electrode like this. Okay. So this H plus will go and accept these electrons and it gets reduced. So that means here reduction takes place at this electrode. Reduction takes place means this electrode becomes the cathode. So the cathodic reaction is two H plus ions are going and combining with two electrons and producing hydrogen gas. Okay. Then here what happens is Cl minus is coming towards this electrode and here it is releasing electrons. That means removal of electrons. Removal of electrons means oxidation is taking place. Oxidation always takes at the anode. So this becomes the anode and the anodic reaction is 2Cl minus will produce chlorine gas by releasing 2 electrons. So here we have to find the overall reaction. Now here we don't have that problem. Here also 2 electrons, here also 2 electrons. So we can straight away mark this as the first equation. And mark this as the second equation. And then add 1 and 2. When we add 1 and 2, when we add 1 and 2, on the left hand side we will get 2H plus 2Cl minus and the 2 electrons here. And on the right hand side also we will get H2 gas, Cl2 gas and 2 electrons. Okay. Let's come to the next slide. There's another example. Electrolysis of aqueous copper sulphate. Here the electrolyte is aqueous copper sulphate and we have two electrodes, carbon electrodes, and we have connected it to a electricity source. Here also we are using aqueous, so there is water. Water is present. So because water is present, water molecule will break into two as H plus and OH minus. And copper sulphate will break as Cu2 plus and SO4 2 minus. Now here also there are 4 ions, 2 positive ions and 2 negative ions. So here also you can find a competition. Here also you can find a competition as to like who will go and get reduced, who will go and get oxidized. So let's first of all let's identify what is the positive electrode and what is the negative electrode. This electrode is only connected to the positive terminal of the battery. So this will become the positive electrode. Okay. And this electrode is only connected to the negative terminal of the battery. So this will become the negative electrode. Positive ions will get attracted to negative electrode and negative ions will get attracted to the positive electrode. Here also now there is a competition. Cu2 plus and H plus both are there. Who is at the bottom of the activity series? Go and see who is at the bottom of the activity series. you will find out that copper is at the bottom of the activity series. So because copper is at the bottom of the activity series, copper will get the chance to reduce. Copper will come near this electrode. By the time these electrons have come like this and the electrons are here. Okay. And from these two, from SO4 2 minus and OH minus, who will go and get oxidized? Normally you remember like this SO4 2 minus, it's a little bulky, like it's too lazy to move here and there. So this OH minus will only come near this electrode and this OH minus will get oxidized. So because this Cu2 plus is going and accepting electrons, this becomes the cathode. And here because oxidation is taking place, this becomes the anode. So the cathodic reaction is Cu2 plus will go and accept 2 electrons and it will become copper. Here you have to balance the equation because, okay, then let's come to anodic reaction. Here what happens is 4OH minus will break into oxygen gas and release water and release 4 electrons. This electrolysis is like used in many industries, like to extract metals, like that in electroplating, like that. There are many uses of this electrolysis. Today we'll be discussing about one of the uses, that is industrial production of sodium metal. This sodium does not exist alone in the nature, so we have to extract this sodium metal. Sodium exists as sodium chloride. So here from this sodium chloride we have to remove sodium separately and take. To remove this sodium from sodium chloride, we have a special setup called down cell. This is the down cell setup. Here you can see here the raw material we are using is sodium chloride. Here we are using the raw material sodium chloride. And there are 2 anodes on either side. There is 1 anode in the middle and there are 2 cathodes on either side. The anode we are using is graphite anode. We are using a graphite anode and we are using 2 steel cathodes on either side. Let's see what happens. From here, we will put sodium chloride. We will put sodium chloride, that means our raw material, we will put it in here. And we know that our cathode is negatively charged and our anode is positively charged. So here we are using our raw materials. Our raw material is sodium chloride. So there should be, in this setup, there should be sodium plus ions. There should be sodium plus ions and Cl minus ions. So in this solution, there will be sodium plus ions and Cl minus ions. So now here the positive electrode is graphite, the anode. What happens? The negative one will only get attracted to the positive one, so Cl minus will come here. Cl minus will come here and it will produce chlorine gas and it will release 2 electrons. This one will release 2 electrons. The electrons released by this anode will get embedded here. The electrons released by the anode will get embedded here. So you can see now this is the anode. The anodic reaction is Cl minus to Cl minus. This Cl minus comes from the raw material sodium chloride. Cl minus will release chlorine gas and it will release 2 electrons. These 2 electrons will come and get embedded on the cathode. Then what happened? The cathode is negatively charged. You can see the cathode is negatively charged. Then positive gets attracted to negative, no? So this sodium plus ion will go here. Sodium plus ion will come here. And the sodium plus ion will combine with this electron and it will form sodium liquid. Sodium plus will combine with the electron and it will form sodium liquid. So through this, we can take the molten sodium out and we can use it separately. You can see here they have used the steel grid in between the cathode and the anode. In between the anode and the cathode, they have used the steel grid. Why have they used the steel grid in between these two? The reason is now here we are using fused sodium chloride. No, we are using fused sodium chloride. So Cl minus ions will be here and sodium plus ions will be here. If we don't put this steel grid in between, what happens? These two will again come together, combine and form sodium chloride. To prevent the combination of sodium plus ions and Cl minus ions only, here we are using a steel grid in the middle. And also to this setup, we are adding 40% of calcium chloride. Why are we adding 40% of calcium chloride into this setup? Normally, the melting point of sodium chloride is 840 degrees Celsius. Here, to break this sodium chloride, we have to break sodium chloride and Na plus ions and Cl minus ions should form. So to break this, the melting point is 840 degrees Celsius. That is a very high temperature. So that means we will have to heat this for a long time. To bring down this melting point only, we are using calcium chloride. When we add 40% of calcium chloride to this system, what happens is the melting point comes down to 600 degrees Celsius. So within a short time, we can break the sodium chloride into sodium plus and Cl minus. There are so many uses. We take sodium separately and chlorine separately. There are so many uses of sodium and chlorine. Chlorine is used as bleaching and chlorine is used to produce plastic and sodium is used to make sodium vapor lamps and sodium is needed for laboratory experiments like that. There are many uses. So to use them separately only, we are using this method. This is an example of electrolysis used in the industry. The industry is production of sodium metal. Here also you can see they have taken the overall reaction. Here there is 1 electron and 2 electrons. So this also we have to make this also 2 electrons. So because of that, this is the first equation, this is the second equation. First equation we are multiplying by 2. Then we will get this. Then we will mark this as the third equation and we will add the second one and the third one and we will get the overall reaction. This side also there are 2 electrons, this side also there are 2 electrons. So this will get cancelled off to this one. Okay. And another use of this electrolysis is electroplating. I will teach you about electroplating with another video. And most of you have requested lessons from me. I will make sure that I upload them as soon as possible. And if you want any lessons, you can comment below and I will try to respond very soon. If you have any doubts, you can call me and clarify them. Okay, that's all for today. God bless you.